Okay, they say a certain amount of nitrogen dioxide gas is sealed in a gas syringe. When equilibrium is reached, the volume occupied is 80 cubic centimeters. We do not have cubic centimeters, guys. We need to convert it to cubic meters. The balanced chemical equation for the reaction takes place is 2NO2 and it forms NO4. So now they say at equilibrium, the concentration of NO2 is this. The equilibrium constant is given 171. And now they say calculate the initial number of NO2 in the gas syringe. All right, so let's now go to our table. So we have 2NO2. Okay, and we are forming N2O4. So this is plus, this is minus. Okay, now let's read again what we have. Okay, at equilibrium, we have 0.2 moles per cubic decimeters, and it is for NO2. Okay, so we start here, 0.2. That is the concentration we have. All right, so now we need to change the volume. Okay, so 80 cubic centimeters is then we need to divide by 100. Yeah. So it's 80 divided by 100. So am I correct? Do I divide with 100?
So isn't it 1,000?
Is it 1,000 cubic centimeters to cubic decimeters?
Yes, sir.
Are you sure, Tafiwa?
Yes,
Or
sir.
Safari?
Yes, Chifiwa, sir.
Huh?
Yes, sir.
Is it correct?
I think
I always
so.
forget this. I must always just remind myself about this. So divide by 100 or 1,000? Yeah, it's 1,000.
So
it's 1,000.
Yeah, it's 1,000.
Yeah.
Okay. So we need to divide the 0.80 divide by 1,000. So your answer for your volume will be 0.08. Okay, why did I want to do it by 100? Because normally we divide by 100, but remember it's times to the power 3, so it's divided by 1,000. Okay, so it's 80 divided by 1,000 is 0.08 cubic decimeters. So now, what do we need to do? We need to now go up, and we need to now go from there to there. Okay, that's the very first thing. So we take the 0.2 and we times it by 0.08. Okay, so the answer now is it 0.16? Everybody agree?
So it's so you said 0.2 times. What's that number?
0.08.
It's 0.016.
0.016.
Yes, sir.
No. Let me just rewrite that one clear. So it's times 0.08. So you say the answer is 0.016.
Yes,
Okay,
sir.
everybody happy with that? All right. Now, we go up and we just quickly go and look here. They don't give us any initial things because that's what they want. They want NO2. Okay. So what I'm going to do is I'm going to make NO2 X. All right. Because that is the one that we are looking for. All right. So initially there's no NO2. So I'm making that my unknown, which is X. What else do I know? I know in the beginning, there's no products. All right. So what minus what gives me 0,016? So we need to go and find out what is this answer. If you look here, this is what they gave us. We can convert it to moles, but they want the initial value there. So we need to have the change to actually get to the rest. But they gave us here something, and this is what I'm actually, where I got lost, was they gave us the KC there. So if you go and work out the KC from the beginning, all right, instead of us making it so difficult with quadratic equations, okay, so let's work out our KC. Okay, so it is then N2O4. Okay, and we have NO2 squared. All right, so the KC is 171. All right, so we can go and work out what is the concentration of N2O4 actually. Why do I say that? Because we know what is our equilibrium concentration of NO2. Okay, so we square this and we can get the concentration of N2O4. So this will then be equal to 171 times 0,2 squared. Okay, so now we get to our answer there. 171 times 0,2 squared, and this the answer is then 6,84. All right, so then I'm coming back. So the answer here is 6,84. All right, so now I'm going upwards like I did with the previous one. So I'm going up, so I'm going to multiply with 0,08. So I'm taking 6,84 times 0,08. Okay. And we get 6,84 times 0,08. We get then 0,5472. Okay, so now the change would have been then 0,5472. Why do I say that? It's because 0 plus 0,5472 is 0,5472. Now we can go and work out the change. You see it's a bit easier. It's not so complicated with the maths. So you take it up. You divide. What are you going to divide with? There's a 1. Then it's going to go across. Multiply. What are you going to multiply with? By 2. So this will be 0,5472 times 2. Okay, it will be times 2. So the answer here is 1,0945. 4. Okay, and now we can take this equation. Okay, so if we add another blank page, we can then say x minus 1,09444 is then equal to 0, is it 16? 0,016. Okay, and then we solve. Okay, so we take the 1,0944 plus the 0,016, and the answer is 1,1104, and that's the number of moles for NO2 initially. So, Khwari,
Yes, sir.
did you work out the X with our previous one?
Oh no, so it didn't work out in the end.
Yeah, I also thought so. Now, when
Yeah.
it became like that, I saw no, something was missing. All right. So,
Yes, sir.
what was different here, guys? Okay, just to recap, they gave you the Kc. They gave you the equilibrium constant of equilibrium concentration of NO2. So you can now go and work out the equilibrium concentration of the other one. Okay, and then you should use this one to actually get the change, and then to go and work out the X, which we have at the end. All right, guys. Any question